In today's video, we are going to focus on acid, base, and salts. Many acids and bases occur naturally in nature, such as citric acid in fruits like orange and lemon, tartaric acid in tamarind, malic acid in apples, and lactic acid in milk and other milk products. We use most of these acids in our day-to-day life, such as vinegar and acetic acid in the kitchen, boric acid for laundry, and baking soda for the purpose of cooking. Acids, bases, and salts are three distinct classes in which all organic or inorganic compounds are classified. Many of the acids that we do not consume in the household are used in laboratories and industries. Acids such as HCl and H2SO4, and also bases such as NaOH and KOH. When these acids and bases are mixed in the right proportion, the neutralization reaction does result in the formation of salts and water. Some naturally occurring salts are found in nature, and they include NaCl, KCl, etc. They are found in salt water and natural rock deposits. So in today's video, we are going to learn more about acid, base, and salts, and also their properties. First of all, let's look at Arrhenius' concept of acid and bases. So according to his concept from 1787, acid is a substance which dissociates in aqueous solution to give hydrogen ions. In general, the ionization of acids takes place as follows. For example, substances such as HCl, HNO3, CH3COOH, and HCN, etc. are acids simply because they ionize in aqueous solution to give out hydrogen ions. On the other hand, base is a substance which dissociates in aqueous solution to give hydroxide ions. The general ionization of base takes place as follows. Substances such as NaOH and KOH are bases because these compounds ionize in aqueous solution to provide hydroxide ions. So, according to Arrhenius' concept, acids gives hydrogen ions, while bases give hydroxide ions in water. Examples of some of these important acids and bases include hydrochloric acids, nitric acids, sulfuric acid, and phosphoric acid. And then under bases we have sodium hydroxide, potassium hydroxide, calcium hydroxide, and aluminium hydroxide. Now there are certain limitations to the Arrhenius concept. Number one is this concept is applicable only in aqueous medium and do not explain the nature of acids and bases in non-aqueous medium. Number two, according to this concept, acid and bases are only compounds that contains hydrogen ions and hydroxy ion respectively. It can't explain the nature of compounds such as CO2 and HN3, which are acids and bases respectively. Although this concept has limited scope yet, it led to the development of more general theories on acid and base behaviors. Now, let's move over to Brønstien-Lowry's concept. In 1923, the Danish chemist Brønstien and an English chemist Lowry independently presented their theory of acid and bases on the basis of proton transfer. And their concept goes like this. An acid is a substance, molecule, or ion that can donate proton to another substance. And a base is a substance that can accept proton ions from another substance. For example, HCl acts as an acid while NaH3 acts as a base in the chemical reaction below. And also, simply, when HCl dissolves in water, HCl acts as an acid and H2O as base. It is a reversible reaction actually, In the forward reaction, HCl is an acid as it donates proton, whereas H2O is a base as it accepts proton. In the reverse reaction, Cl, that is chlorine ion, is a base as it accepts proton from the acid H3O ions. Now, chlorine ion is called a conjugate base of acid HCl, and H3O ions are called conjugate base to H2O. It means every acid produces a conjugate base and every base produces a conjugate acid. According to Brest-Lawrence concept, an acid and a base always work together to transfer a proton. That means a substance can act as an acid, that is, a proton donor, only when another substance simultaneously behaves as a base, a proton acceptor. Hence, a substance can act as an acid as well as a base, depending on the nature of the other substance. For example, H2O acts as a base when it reacts with HCl, and as an acid when it reacts with ammonium. Such a substance can behave as both acid and as well as base, and they are called amphoteric substance. It has been observed that there are certain substances that can behave as an acid, though they don't have the ability to donate proton, e.g. SO3. Similarly, CaO behaves as a base but it cannot accept proton. This observation proves the limitation of Brunson-Lowry's concept of acid and base. Now, let's look at Lewis' concept of acid and base. The Arrhenius and Brunson-Lowry's concept of acid and bases are limited to substance that contains proton. So Lewis, in 1923, proposed a more general and broader concept of acid and bases. So according to his concepts, an acid is a substance, molecule or ion which can accept a pair of electrons while a base is a substance, molecule or ion which can donate a pair of electrons. Now let's summarize the Arrhenius, Brunson-Lowry and Lewis concepts of acid and bases. So according to Arrhenius, acids gives off hydrogen ions and bases gives off hydroxy ions. While according to Brunson-Lowry's concept, acids donate hydrogen ions while bases accept hydrogen ions. Now according to Lewis' concepts, acids are electron pair acceptors while bases are electron pair donors. Now let's look at the general properties of acids. So first of all, let's look at the physical properties. Acids have sour taste, for example, unripe citric fruits or lemon juice. And again, they turn blue litmus paper red. They are corrosive in concentrated form. And also, their aqueous solution conducts electricity. Now, let's move over to the chemical properties of an acid. Number 1, reaction with metals. Acids react explosively with metals like sodium, potassium, and calcium. However, dilute acids like HCl or H2SO4 react moderately with reactive metals like magnesium, zinc, iron, and aluminium to form respective salts with the evolution of hydrogen gas. Now we have reaction with carbonates and bicarbonates. Acids react with carbonates and bicarbonates to form corresponding salts, with it giving off carbon dioxide gas. Then we have reaction with bases. Acids react with bases to form salt and water, and this process is called neutralization. Reaction with sulfites and bisulfites. Acid reacts with sulfites and bisulfites to form salts with the liberation of sulfur dioxide gases. Then we have reactions with sulfites. Acids react with metal sulfides to liberate hydrogen sulfide gases. Now let's move over to the uses of acids. Benzoic acids are used as food preservatives, while nitric acid is used in manufacturing fertilizers, explosives, paints, drugs, and etching design on copper plates. Then, sulfuric acid is used to manufacture fertilizers, ammonium sulfide, calcium supersulfide, explosives, paints, dyes, etc. It is also used as an electrolyte in lead storage battery. Hydrochloric acid is used for cleaning metals, tamine, and in printing industries. Acetic acids are used for flavoring food and food preservatives. Now we have naturally occurring acids, and they include citric acids, which are found in citric fruits like lemon and oranges. And also we have lactic acids, which are found in sour milks. And we have formic acids, which are found in the stings of bees and ants. Also we have malic acids, which are found in apple, uric acids, which are found in urine, and stearic acids, which are found in fats. Now let's move over to general properties of bases. Under the physical properties, we have bases have bitter tests and they feel slippery. For example, soap is slippery to touch. And also, they turn red litmus paper blue. They are non-corrosive except for concentrated forms of NaOH and KOH. Their aqueous solution also conducts electric currents. Now, again, let's look at the chemical properties of bases. Number one, we have reactions with acids. Bases react with acids to form salt and water, and this is called neutralization reaction. We have reaction with ammonium salts. Alkali reacts with ammonium salts to liberate the ammonium gases. Now let's move over to the uses of bases. Sodium hydroxide is used in manufacturing soaps, while potassium hydroxide is used in alkaline batteries. Magnesium hydroxide is used as a base to neutralize acidity in the stomach, and it is also used for the treatment of bee stings. Aluminum hydroxide is used as a foaming agent in fire extinguishers. Now let's move over to pH scale. A solution of a compound with pH 7 is considered a neutral solution, while solutions of compounds with a pH less than 7 are considered acidic and more than 7 are bases. So with this we can say a pH of a neutral solution is always 7, and acidic solutions have pH less than 7, while basic solutions have pH value greater than 7. Alright, this is where we are going to stop this video. You can find other materials and study more on your acid, base, and salts, and also try learning all those reactions. And see you in my next video. Bye.